quickly go to page number 357 of your book and let's give it a go to question number 10, please. Go for it. So 5,000, part 4. 5,000 equals to 29,000 minus 0.25 times n, and just solve for n, you get the answer. Yes? Make sense? All good? No dramas so far? Alright, let's jump on and quickly do question number 13, please, which is a multiple choice question. Question number 13. Whosoever is ready with the answer, give me the choice number and I need an explanation why. And in the meantime, I'll take this off from the board. Yes, answer. Who's ready? Choice number. Gabby, choice number.
I haven't done it yet.
Michelle?
Haven't done it
Gabby, you don't have the clue of how it's going to be done?
yet. No, I understand, but like I know it's not for the incorrect one, but
Do some elimination if you can. Tanu, what's the choice number?
I'm still working.
Alright, time's up. Who can tell me? This was a slight twist. A slight twisty question. Tanu, if you were to pick up one choice, let's say you won't leave it blank, right? At the end of the day, you'll still pick it up. You know, it's multiple choice. Let's say you're not expected to show any steps. Pick one choice. What would be your best guess? Anyone else who's closer to the values that's written? Choice number D. Choice number D is the right answer. Now, let's see what the question is telling us. It says the value of the bike which is purchased, so that means your V0 is $3,800. Correct?
Yeah.
Any doubts in this one? V0 equals to 3800. That's the first term. The value is getting depreciated 10% per annum. Can you tell me what will be V1 if the value next year is 10% less? Can you tell me what will be the value? Who's telling me that? Come on, pick your calculators. Tell me. This has gone down minus 10%. What will be this value?
3,420.
3420. Now, Tom, did you get this?
Yeah.
Michelle, did you get this?
Yeah.
How is the question? How did you get this? One by one, let's hear each one of us. Tom, how did you arrive? This is the right number. How did you land on this spot?
I got 10% of 3,000.
How did you do that? What did you do on your calculator?
So 10 over 100 times 3,800, and then I got 380.
This is what you learned, right? Pretty much.
Yeah.
Yes. What did you do? Exactly the same thing or anything different?
No, I just know that 10% of 100 is 0.10, so I just did 3,800 times 0.10.
And Mitchell?
So you times it by 10, cut. So 3,800 times 0.10, then you get 380, then minus that.
Same thing. This is, if you were to, what do I say? If you have to hold your nose, how will you hold it? That's the way to hold it, right? You've gone this direction. Try to hold it like this. You still held your nose, but then slight difference. If you have to now, percentage shortcut is very important. If you have to find, if the value is, let's say you had this bike for $3,800 in the shop and say, okay, buy it for 10% discount. So one way is getting to this price, and that's the price, right? But then the other way of doing it is, what is 100? You take it off from 100, you get 90. So basically, you're paying 90% of this cost, and that's your 10% discounted price. So what I'm trying to do is, why don't you simply find 90% of 3,800 or 0.9 times 3,800? Do 0.9 times 3,800, you'll land at the same spot. VC is all about saving time. You would have lost easily a few seconds here. Very important, right? So whenever something's losing value by a percentage, you take away that value from 100, whatever is left times the previous value is your current value. Make sense? So what I'm trying to do here is my Vn plus 1 is actually 0.9 times Vn, is it not? Now next year, so this is V1. So now Mitchell, next year what? 0.9, 10% off this is this one, right? So 0.9 times 3,420. Right? And what am I after? It says, which one will be which of the following recursive calculations is not correct? So obviously A is the right answer. A is the obvious choice. A is the one of the choices which are right. Obviously, I'm trying to find something which is not there, which is incorrect. So V0 equals to 3,800. That's the right choice. The A is correct. Even B is also correct, right? V1 equals to, the first term is 90% of the previous term. So when B is right. Danu, are you confused? You okay?
Yeah.
Right? Part C, V2. Now what will be V2? 90% of 3420. We just calculated that, right? Danu, are you confused? You okay?
Yeah.
Right? Part C, V2. Now what will be V2? 90% of 3420. We just calculated that. So even your choice number C is also right. We are after something which is incorrect. Choice number D. What will be V3 now, guys? Can you just quickly do 3420 times 0.9? What would that be?
3078.
Sorry?
3078.
3078.
Yeah.
So your V3 is 0.9 times 3078. Correct? What is written in choice number D? What is written in choice number D? So D is the correct answer for the question, but wrong figures for the question, which we are after. Expect these questions in the exam. Not very straightforward ones, right? Does that make sense? Absolutely.
Yeah.
Any problems so far? Let's quickly do one more, right? Let's give it a go. Question number 14 now. Get your heads into it, quick. It's 7:12 by my watch. I will take it, I'll ask the answer 7:14. I'm taking this off the board in the meantime. Gary, what's your choice?
C.
Michelle, what's your choice?
A.
Dana, what's your choice?
C.
C is the right answer. Good job. Now who's going to explain me? Gabby, explain me how C.
Well, the original value is 4,280, and then well, that's the first part. But then to get a recurrence relation, we need to make Vn plus 1 equals Vn plus D.
Correct.
That's the formula. So A is incorrect because you can't do two values, so you can't do Vn plus 1 plus Dn, because then that's the wrong formula. And then minus is incorrect, and then C is correct because it's adding the 25 value.
Make sense?
D and E are just incorrect.
Make sense? Right? So straightforward. This was, you've given the recurrence relation, and obviously C has what? C is Vn plus 25, right? So that's where it is incorrect. Now, all good? So we've straight away covered concepts until 7C now. Let's go to geometric sequences, and let's talk about compound interest now. This is something which is very, very important. Now, we've got some time, I think. I will try to explain you something very, very important from a compound interest perspective, because that will be heavily used when you use your financial maths, right? Which is your annuities, perpetuities, loans, etc., and investments. So, compound interest has a formula of A equals to, and I'll tell you what A is, P of 1 plus capital R raised to the power of N, where your capital R is R over 100, small r over 100, or probably if you'll see a few books using even this formula, and they say R equals to 1 plus. But and you'll see a few books straight away writing the formula like 1 plus small r over 100 raised to the power of n. We just discussed what is compound interest, right? Your compound interest pays you interest of your last outstanding balance, right? P is the initial principal, the amount that you've invested. R is the rate of interest. And only 10 N, do you know what is N?
The years.
Sorry?
The years.
Yes and no. If it is a year, if it is compounding annually, it is years. Have you heard of the word called compounding periods?
No.
What is a compounding period? Sorry, I'm not putting you on the spot because we've done that, so probably, it's good that, someone's done in the room. Do you know what is a compounding period?
Like how long it compounds?
Yeah, roughly. How many times do I need to compound? Alright, when I say compound, that means apply the interest. N tells me, this power, N tells me how many times in a year, in the frame of the question, I have to apply my interest. What does that mean? Very, very important concept, very, very important. I've seen students fumbling on this, right? Especially with financial maths when they use their financial calculator. Let's take an example. Let's say I have $1,000, right? And I need you to have your calculators in hand. You've got $1,000 and you go to a bank. Let's say there are two, I'll take the same analogy. Two people have $1,000 each and they go to obviously two different banks. Now bank A and bank B. Bank A says, all right, I'll pay you 12% per annum compounded yearly. Bank B tells you, that person, that okay, I'll give you 12% again per annum, but I will do compounding quarterly. Alright? Loud and clear. Hear me out loud and clear, okay? If you don't understand, tell me. What it actually means is that this guy, and let's say you kept your money for 2 years. These guys have kept their money for 2 years, right? Now, something interesting is going to happen here. Compounding yearly guy will apply the interest or will pay the interest twice in the time frame of 2 years because it's compounding yearly. First one at the end of first year, the second one at the end of second year. But then the concept of compound interest still remains the same. He's going to look at your last outstanding balance, blah, 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 and you pay that. So, if I apply this formula here, for this person, let's see how much do we get. And I need you to use your CAS. A is the amount that this person gets after n compounding periods. So in this case, in the first case, how many times have we compounded? 2. So my n is 2. And at each compounding period, how much rate have I applied? 12%. Last outstanding balance, blah, 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 and you pay that. So if I apply this formula here, for this person, let's see how much do we get. And I need you to use your CAS. A is the amount that this person gets after n compounding periods. So in this case, in the first case, how many times have we compounded? 2. So my n is 2. And at each compounding period, how much rate have I applied? 12%. R is 12. What was my starting principal? 1,000. So can you quickly plug into your CAS and tell me the amount after 2 years by this simple formula? It's A equals to 1,000, 1 plus R is the rate of interest, is the 12 over 100 raised to the power of the compounding period, which is 2. Can you tell me what's the answer here?
1,254 and 40 cents.
$1,000.
$254 and 40 cents.
Cool. Right? Let's go here. I'll use a different color. This guy is compounding quarterly. So how many times this guy will compound in 2 years' time? 8. N is 8. In each of its compounding, it's compounded 8 times, right? How much rate of interest he's going to plug in, apply? Sorry, this is bad handwriting, this is 12. 12% per annum. What will be the rate of interest? You said R is 12 here, right? What would be the rate applied in each compounding?
Divided by 4.
12? Or divided by 4?
Not sure.
If I am going to pay someone quarterly and I've agreed on a yearly rate, what will I do every quarter? I'll divide by 4 and give that person that percentage, right? Every year, every quarter. So basically, the rate R, I will just divide it by, how many quarters do I have in a year? 4. So basically, 3%. So in a quarter, if I give 3%, in a year, I give 12%. Maths is very, very straightforward, right? I'm not giving that person anything more. This guy also agreed on 12%. We agreed on 12%. Okay, you want to take it quarter, that's fine. I'll give you 3%. 3 times 4 is 12. No harm to me. Make sense? Now, but my R is 3. Now go into your calculators and find A equals to, if you've not already found, 1,001 plus 3 over 100 raised to the power of n is 8. Give me the answer.
1,266.78.
Danu, did you got the answer?
Yeah.
Michelle? Sorry? Oh, you don't have cash. That's okay. What's the answer? Come on.
1,266.77.
Just look at the amounts. Same amount, same rate of interest. The only difference is this word. That is the magic of compounding. The more you compound in a year, the more your investment grows. Right? Does that make sense? If this would have been compounding monthly, then let's see what's the amount. If it is compounding monthly, so Michelle, how much would be N in that case?
If it was compounding.
Monthly, and I'm investing it for 2 years. 2 years,
24.
so 24. Good. And what would be R? I'm doing 12% a year and I'm compounding 12 times in a year. So how much? 1% each year, each month, right? R is 1. Now try A equals to 1,000, 1 plus 1 over 100 raised to the power of 24. Can you get me the answer? On your CAS. Done? Got it?
I got $1,269 and 73 cents.
70?
Three.
You see, another $3 comes into your account, this guy's account. So what has happened actually? Think this is daily. You'll go crazy. Even more money. Right? And I tell you, that is why when you take loan from banks, they compound their interest daily so that they can suck maximum out of your pockets. But that's the maximum. They can't apply hourly interest now, right? They can stop only at days. So n value is, so let's say if you've taken a loan for 5 years, 365 times 5, that's the value of n. But then at the face of it, it looks like, oh, 12% a year. Doesn't make a hell of a difference. Right? So in the formula, R and N are very important. N is not the number of years. N could be number of years if you're compounding yearly. N is called compounding period. And how do you find compounding period? The word after compounding tells you how much is n. So if your time is time times whatever is here, your compounding period, you know, your this value here will give you compounding period. Does that make sense? 100%? For a few minutes. See, the concept is very, very important to learn. Right? Questions, once you got it, then questions would be easy for you to understand. So, I'll probably explain, we'll do questions maybe next week. But now, shall I take this off the board, please? All of it? So I'll just sum it up now for you, what we've learned today. My recursion, the world of recursion has arithmetic sequence and geometric sequence. My arithmetic sequence has growth and decay. My geometric sequence also has the same thing, growth and decay. Growth is when my D is positive, common difference is positive. Decay is when my D is negative. And we'll study next week the way we've got common difference. We've got something called common ratio, R. R being positive is a growth and R being negative is a decay. For growth, the most realistic example is simple interest. Problems that are in the purview of your book of a VCE. For decay, you've got the flat rate, flat depreciation, and your unit depreciation. And in here, your growth is compound interest. We just talked about it. Right? And your decay could be your regular decays, right? You know, your bacterial decays. You'll have many problems here. Right? Your even some part of your unit depth is also a decay, but then we'll talk about it. And you could have anything which is decreasing, right? Let's say population of a country is decreasing because of COVID, for example. So population decay, right? And so on. Anything which is going down exponentially is your decay, right? So with that, I will stop today and I will see you next week.